Today's lesson is on using congruent triangles while doing proofs. In looking at our first proof, we have some given statements showing congruency, but we're trying to prove that a set of angles are congruent. So the big idea here is that if we first show that the triangles are congruent, then we can say each of the pieces are congruent, whether they're angles or sides, because of CPCTC, which stands for corresponding parts of congruent triangles are congruent. So let's start by marking the diagram. So I have segment WO is congruent to segment ZO. That's a given, so that's a side that I have congruent. And I also have segment XO is congruent to segment YO. That's again another side. So I have two sides that are congruent. I need to look for either an angle that's in a good spot that will show congruency or another side. And I do notice that I have vertical angles and they're congruent. So I have angle WOX is congruent to angle ZOY, and that is because vertical angles are congruent. Now again, that gives me an angle. So now I have enough. On my left-hand triangle, I have side angle side. On my right-hand triangle, I have side angle side. So I can say triangle WOX is congruent to triangle. Now I have to be careful how I match up the letter. So I have angle W matches up with angle Z, so it's going to go next. O matches up with O, and X matches up with Y. And I can say the reason for that is side angle side postulate. Now that I've shown that the triangles are congruent, I know that all the corresponding parts are congruent, so I can use my last step now. Angle W is congruent to angle Z, and that is because of CPCTC, which stands for corresponding parts of congruent triangles are congruent. In looking at our next proof, we have some parallel lines in here, both with the given and the proof. So let's try to figure out where we're trying to go. It says segment ZY, so I'm going to mark that kind of with a dot for now. I'm trying to prove that ZY is parallel, that segment is parallel to WX. Now, how can I do that? It looks like I have a transversal here in the center. So if I'm trying to prove that segment ZY is parallel to segment YX, if I can show that angle 1 is congruent to angle 2, that would help me because they're alternate interior angles. Now again, how do I do that? Well, I have two triangles. I do have a congruency statement in my given, and I have another set of parallel lines. So if I can show those two triangles are congruent, I could then say angle 1 and angle 2 are congruent because of CPCTC, and then I could go to my last statement, which is segment ZY is parallel to segment WX. So that's going to be my plan for now. Alright, so let's get started and see how I do. So I have ZW, let's use a different color here. I have ZW is parallel to XY. I'll keep that transversal in red, and that's given. So how does that help me? Well, if that's true, I can say that angle 3 is congruent to angle 4. Angle 3 is congruent to angle 4 because they're alternate interior angles. So I need to say if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So that gives me one set. My next given statement tells me that segment ZW is congruent to segment XY, and again that's given. So I'm going to mark that diagram. So I have ZW and I have XY. So now I have an angle and a side, and I notice what happens in a lot of these proofs with congruency, I do have a reflexive piece. So I can say segment ZX is congruent to segment ZX, and that's because of reflexive. And now I notice that I have a side, an angle, and a side on my left-hand triangle, and the same thing, I have a side, angle, side on my right-hand triangle, so I know that I can say that these triangles are congruent. So I can say triangle ZWX is congruent to triangle. Now I have to be careful how I line them up. X lines up with Z, Y lines up with W, and then I have XY, and then my last letter there is going to be Z. So triangle ZWX is congruent to triangle XYZ, and that is because of side angle side postulate. Now, if you remember when we originally started this proof, we said the idea is we had to try to get angle 1 and angle 2 congruent in order to show that those lines are parallel. So we can say that now. So step 6 is going to be angle 1 is congruent to angle 2, and that is because of CPCTC. Now, you can only use CPCTC once you have shown that triangles are congruent, which we did in the step before. So that's how I can say angle 1 is congruent to angle 2. And now because of that, if that red line is still my transversal, and I'm looking at the parallel lines on top and bottom, I have proven that 1 and 2, which are alternate interior angles, are congruent, so therefore I can say those lines are parallel. So I'm ready for my last step. Segment ZY is parallel to segment WX, and that is going to be if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. And looking at our last proof for today, again, I'm going to have to use congruency. I have a set of angles that are congruent, and I'm talking about a midpoint. And I'm also here trying to prove that O is the midpoint of RQ. So again, let's try to figure out what our goal is. If O is the midpoint of RQ, that means that I need to say before that RO and OQ are going to be congruent. So how am I going to do that? I need to show that these triangles are congruent, and then I can show that those two pieces are congruent, segment RO and segment OQ, because of CPCTC. So let's get started with marking up our diagram with our given information. So I have angle P is congruent to angle S, and I have O is the midpoint of PS. Now, if you remember by the definition of midpoint, that does allow us to go right to congruency. So if O is the midpoint of PS, I can say that segment PO is congruent to segment OS, and that is because of definition of midpoint. So I'm going to mark my diagram. So I have an angle and a side. So here's my side here, and here's my angle. And it looks like, again, there's that vertical angle piece that keeps coming up. So I can say that angle ROS is congruent to angle POQ, and that is because vertical angles are congruent. Now I have a side and an angle. There's my last angle. I check my diagram. I have angle side angle on my left hand side, on the bottom my triangle, and the top triangle is also angle side angle. So I can say that these triangles are congruent. So I can say triangle POQ is congruent. Now again, I have to be careful when I match up these angles. So angle P matches up with angle S, O matches up there, and so I have angle R. So I have triangle POQ is congruent to triangle SOR, and that is going to be because of angle side angle postulate. So as we continue this proof, we realize now that I am ready to say that our statement segment RO is congruent to segment OQ because of CPCTC. Remember, that was kind of our goal so that we can get to our midpoint. Once I state that, I can say that O is the midpoint of segment RQ, and that is because of definition of a midpoint.